All right. So what we're going to do with solve equations is this is very similar to seventh grade last year. Keep in mind that the number one thing we want to do is the whole goal is to get the variable by itself. We're only dealing with one variable, so we want to make sure we see what that variable is going to be. So that's our goal. Always, always, always. What are we trying to do? Get the variable by itself. Now, the problem is here, there's some things I can't tell you, like these are the steps, because when you have more than one item, there's going to be a lot of possibilities you could do. So here's some recommendations. Number one, how many variables are there? They're all going to be the same variable, but how many are there? One, two, three. Let's see. If there are any type of parentheses, we want to make sure we get rid of them, right? Because it's a very quick and easy thing to get rid of right away. The nice thing is to pick a side that you want to get the variables on. It can be the left, it can be the right. It's going to be completely up to you. Um, all the constants numbers without the variables, same idea. Wherever side the variables are, we want to get the constants on the other side. Combine like terms. If there's more than one term, to put them together. Again, recommendations. Here's a big thing. If you multiply or divide, if you're trying to get rid of a number with a variable, then if you multiply and divide, you have to multiply and divide by everything. So that's where it gets a little tricky. So usually I like to keep multiply or dividing for the very last step. And then if it's adding and subtracting, you only have to do it once to each side. All right, so keep that in mind as we kind of go through. So those are recommendations to kind of look through, and I'll talk through. So let's start with the really hard one first. Let's go to word problems. Instead of starting from the basic, let's do the opposite. Let's start with hard, and then get easier throughout the day. So here's our example. Two teenagers made the same amount of money babysitting. They worked the same amount of hours, but they didn't charge the same amount. So Sarah charged $3 an hour, but she required $20 for showing up. Troy charged $7 an hour, but only $4 for showing up. How many hours did Sarah and Troy work last week, and how much money did they make? So let's look at just Sarah for a second. Sarah charged $3 an hour, but she required $20 for showing up. That means basically when Sarah came to the door and knocked, as soon as she walked into the door, they gave her $20. Now after that, every hour she worked, she'd get $3. So if she worked 0 hours, $20. She worked 1 hour, $23. 2 hours, 26, etc., etc., etc. Troy was a little bit different. He says, "Listen, I'm going to charge $7 an hour, but I'm only going to chose $4 for showing up," which means he walks in the door, he gets $4. Now, when I look at this for a second, I'm going to look at Sarah. So I want to look at the variable for a second. One's a constant, one's a variable. So the constant's going to be something that can happen many times. The variable is going to be something that can happen many times. The constant is going to be something that only happens one time. Variable means vary, or like with an A, so it can change. Constant means once. So when Sarah gets there, she gets $20 one time, but she gets $3 for every hour. So what's going to happen is Sarah's going to get $3 for every hour, and she's going to get a one-time gift of $20, or one-time earning of $20, I should say. Troy, on the other hand, is going to get $7 an hour, and he's going to get $4 for showing up. So there's our equation. We know it's equal because of the fact that the first sentence, because of the first sentence, the two teenagers made the exact same amount of money. So I know they're equal to each other. So now what I want to do is I want to look about solving them, right? So I want to look into solving them. Sorry, little hiccup there. So what I have here is I have this idea that I know Sarah has 3h plus 20, Troy 7h plus 4, and I want to know what h is. So I'm going to go back to my recommendations for a couple seconds. One is, how many variables are there? Two. There's a 3h and a 7h. The next couple things I want to do is figure out where they're going to go. I can move them to the left. I can move them to the right. It's completely up to us. There's no parentheses I have to worry about. I don't want to multiply or divide to the very end. So right now I'm going to focus on this. I'm going to focus on the fact that there's a 3h, and I'm going to focus on the fact that there's a 7h. So I want to get rid of one of them. So let's just say I want to get rid of the 7h first. If I have something and I want to get rid of it, I'm going to subtract it. So I'm going to subtract it from both sides. So 7h minus 7h is going to cancel that out. On the other side, I'm going to take 3h minus 7h. That's going to give me negative 4h on the left. The 20 is going to come down. Notice the 7/8 and the 7/8 cancel out, and then I bring the 4 down as by itself. So now if you notice, I used to have 2 variables. Now I only have 1. I only have this 4/8 right here. Right? So now what I want to do is I want to kind of get rid of that 20 next to the h because I want to get the variable by itself. So I'm going to take that constant and move it to the other side. Since it's a plus 20, I'm going to subtract it from both sides. So I'm going to subtract 20 from both sides. That negative 4/8 doesn't get touched, so it just comes down. The 20s cancel out, and then I have 4 minus 20. If I have $4, I take away 20, I'm going to have negative 16. It's far apart here, but I'm trying to keep everything lined up so you see where it goes. So notice now I have negative 4/8 equals negative 16. Now I have the variable all by itself. On the other side is everything else. So now what I'm going to try to do is I need to get rid of whatever is in front of my variable. So negative 4h means negative 4 times h. So I'm going to do the inverse, which is division. I'm going to divide both sides by negative 4. When I divide both sides by negative 4, my negative 4s are going to cancel out. On the other side, my negatives are going to cancel out, and 16 divided by 4 is 4. So my answer is going to be h equals 4. And that shows that they worked 4 hours each. So if they make the same amount, they make 4 hours each. So I'm going to jump a little bit. So I'm going to take those two equations again. 3h plus 20, 7h plus 4, and I know that h equals 4. So if I plug that h in, I get 3 times 4 plus 20, and on the other side, I get 7 times 4 plus 4. Just start doing the math. I get 12 plus 20. Other side, I get 28 plus 4. And I get 32 equals 32. And now I know that Sarah and Troy worked, I can move these things, Sarah and Troy worked 4 hours and made $32. So that's what I'm looking for when I put it all together. That's the kind of the hard part that's going to be on the test. That's going to be the most difficult thing you're going to see on the test is that part right there. We're going to have a couple of things in this section, but that right there is going to be the most important thing you're going to see. We're going to see some angles, but angles are going to be just straight up equations. This is going to be the word problem that's going to give people the most trouble. So if you can do this word problem, that's what we're looking for to get an A. If you're like, I can do some of that, that's what we're looking for a B. If you're I'm really struggling with that, that's when you're in the C or below range. But again, we have a lot of time. This is the first thing we're doing, so we have a lot of time to get this to work out. Now let's look at just a straight up equation. Now I'm going to give you just an equation, no word problem. So it's a little bit easier without the word problem. So notice here we have parentheses. So we learned last year in 7th grade, if you have that 3 on the outside right here, we want to bring that 3 into everything inside the parentheses. Same thing with the 5 right here. That 5 I want to bring into the 4, and I want to bring into the 6. So when I multiply them in, I'm going to just distribute them in. 3 times 2 is 6. 3 times 5 is 15. Other side, 5 times 4 is 20, and 5 times 6 is 30. So now I just have a two-step equation with, equation with 2 variables, and I want to get rid of one. Now, the hard part is, if I was in class, we could talk back and forth. So I'm just going to always kind of go one way or the other. So I'm going to say the same thing. I have a variable here, and I have a variable right here. I want to get rid of one of them. Some teachers will say, some students like to put everything on the left. Some students like to get rid of the smaller ones so you can avoid negatives. Either way, I'm going to say let's get rid of this 20x. So I want this 20x gone. That's all I care about. So I'm going to I confused myself. Instead of getting rid of the 20x, let's get rid of the 15 first. Right? Same idea. Notice that's why I'm saying the flexibility. So I could have got rid of the 20x, but now I'm getting rid of the 15. Right? That's where the flexibility. It doesn't matter which one you get rid of. So I get rid of the 15 first. All right, so 15 minus 15 cancels out. Over here, this is tough. Remember, that's not a 30. What's right in front of it is a negative or a minus. So it's a negative 30 and a negative 15. So back to 7th grade. If I'm down 30 and I'm down 15, then I'm down a total of 45. So now the 6x comes down, the 15s cancel out, the 20x's come down, and then I get a negative 45. So here's where that flexibility, I trip myself up. Now I want to get rid of that 20x. So I subtract 20x from the right side, and I bring 20x to the other side. Notice I didn't touch the 45 at all. It just comes down. My 20x's cancel out, and then I get 6 minus 20 is negative 14. Remember, they're being multiplied. So since they're being multiplied, I want to divide, right? So I want to divide that 14 and get rid of it. So I'm going to divide both sides by negative 14. So I'm going to divide by negative 14, divide by negative 14, and that's where I'm going to get this really weird answer. So this answer is not pretty, but that's fine. Notice my two negatives cancel out. A perfectly good answer is 45 over 14. That's a great answer. It can't not be reduced. It can't be simplified. It can be turned into a mixed number, but it doesn't have to be. Or I can change it to a decimal and I rounded it, so 3.2. So that's what I'm looking for. It's the same kind of thing we did in 7th grade, except it's going to be just a little bit more complicated. All right. Example 3 is going to come across. Now, notice this is going to be, I'm trying to go decline today. So usually in math, we go a little easy, a little harder, a little harder. I'm doing the exact opposite. I want to start really hard and kind of work our way down. So again, notice for a second, I have a 10x over here. I have a 7x over here. I have a 7 right here and a 25 over here. So at this point, whatever I want to get rid of, I could get rid of first. But let's just say we want to get rid of that 7x first. So I subtract 7x from both sides. My 7x's will cancel out. My 25 right here will come down. My 7 will come down. And then 10 minus 7 is 3. Remember, my goal is to get my variable by itself. So I want to get this 3x right here by itself. So this plus 7 has to go away. The inverse of plus 7 is negative 7 on both sides. The 7's cancel out. I bring my 3x down. I get 18 on the other side. And this is where I say 3x means 3 times x. So I divide by 3 on both sides. All right, when I divide by 3 on both sides, I get x equals 6. That's all my answer is. So that's really all the kind of steps. Feel free to this right here is not a bad thing to have on your screen or take a picture of your phone so we get stuck, just to kind of look at the different things. There's a lot of options here. This is not the only thing you have to go this particular way. But if sometimes just looking at a step over and over helps you out, that's what we're looking for. So give these a try, see how you do, and then we'll see how it goes.